Good afternoon and welcome to MetalCon Live. It's great to have you with us today. I'm Judy Geller, Director of MetalCon, here with our expert Zoom driver, Kaylin Burke. Today's MetalCon Live is brought to you by our MetalCon partners, the Metal Construction Association. Todd Kimmel, Chairperson of the Rainscreen Association of North America, or RAiNA, is exploring rainscreen, which is considered to be the gold standard for wall design these days. If you are not an MCA member already, definitely check out all the benefits of membership. Your benefits include a discount on MetalCon exhibit space, so we'd love to talk to you about that. First, a few reminders. The Metal Focus Safety Program continues with Craig Schaffer tomorrow at 4 o'clock Eastern Standard Time. This series has really evolved into a highly dynamic learning environment with a lot of experience sharing. If you can't attend the live session on Zoom, head over to MetalCon Live, click the tab on the MetalCon website and take the courses on demand. Craig will still answer your specific questions. Next up on MetalCon Live is May 5th. Don't miss the popular quarterly trends in metal construction and design. Dave Burstein and Ken Simonson will present the research and the trends in a visual format that will help you plan your strategy for the remainder of 2021. Ooh, this is a tongue twister, and beyond. Finally, if you haven't been on the MetalCon website in a while, you definitely should check back to see all that we've added. Registration and housing are open as always. The education is posted, and there's still more to come. Also, of course, a thank you to our sponsors. If you need any technical help, reach out to MetalCon support in the chat box and Kaylin will respond. And don't forget to complete the post-webinar survey so you can earn your AIA credits for today's session. And I think that wraps it up from me. So I'm going to hand it over to you, Todd.
Great. Thanks, Judy.
You're welcome.
Let's see if I can get this up and running. I assume everyone can see my slide. Can you see my slide, Judy?
Yes.
All right, perfect. Well, thank you, Judy, and thank you to MetalCon for having me and the Rainscreen Association North America here present to your group. I'm Todd Kimmel, as Judy mentioned. I'm the chairperson for the newly formed RAiNA, as I mentioned, Rainscreen Association North America. We are still somewhat in our infancy. We formulated early last year amongst the start of the pandemic, but we've gotten a tremendous amount of work done. And I think there's a lot of people here on this call that might be familiar with us. I know many of you get involved in integrating metal within rainscreens. And so we're going to talk a little bit about that here today and kind of go even deeper in terms of the breadth of what it takes to make a successful full rainscreen. So just quickly, here's the course description that I think Judy went through. The hope and the goal here is to identify some of the common reasons for moisture issues within our wall assemblies. Look at kind of what's currently in the code as it relates to the various elements and the components that we have to consider within rainscreen walls. Looking at the overall performance of walls as it relates to the various functions from air, water, vapor, thermal, and fire. And then, learn a little bit more again about the new association out there, how we can support your efforts and how it might make sense to align going forward. So we'll start with kind of just, again, the building enclosure. We'll look at all the things that we need to consider when it comes to rainscreen, which, as we all hopefully know, and if we don't, we'll know soon, it's more than just a paneling product. There's a lot of other considerations that we need to take in. Why it makes sense that the rainscreen group needs to come together to kind of represent this kind of new gold standard within the enclosure environment, and how the Rainscreen Association works. So I am going to ask the Chief Operating Officer for RAiNA, Laverne Dalgleish, I believe, is in attendance today, and he should be able to assist with answering any questions that you have throughout the course of the presentation. So feel free to type questions within the chat box. If we're unable to answer any of those particular questions, I'll certainly be able to field them at the end of today's program, and we'll hopefully get what you need before the end. It is an AIACU, so definitely, as Judy mentioned, get your contact information in, and we'll be able to get you the credits for today's program. Let's see if I can. What is this? All right, so why moisture problems in wall assemblies? And I think, first we're going to kind of start on a higher level of, how walls get wet, and then also how they dry out. Maybe it's more simplistic, and you're well aware of how walls get wet. I think first and foremost, rainwater is a key element in how walls can get wet. So as we look here on the left, item number one is that rainwater hitting your facade or getting through into the enclosure. But it's more than just precipitation or liquid water that hits the wall that can contribute to moisture within our assemblies, right? We also have to think about vapor permeance, which many of us do, and the diffusion element of higher vapor pressure moving to lower vapor pressure. And item number two here within this wall can kind of showcase how that vapor diffusion can occur both going inwards as well as both going outwards, right? So it depends on the relative humidities within the interior environment versus the exterior environment, which is often driven by the climates that you're in. And so certain climates, you have to navigate that differently. But it is really important to notice how that can work and how we want to make sure we can manage that moisture as much as we do with precipitation. We also should be aware that within construction, we have built-in moisture within our materials, whether or not we're talking about moisture within CMU or concrete that sometimes takes months or years to dry out through our walls. We have to be aware of that. We also know that during construction, materials can get wet, right? Wood can get wet, other materials can get wet. And when we start to close buildings up, that moisture does need to move somewhere. And so we have to recognize how that moves within our walls and how we can evacuate that. And last but not least, we have groundwater, which is identified here in item 4. Maybe not as much of a concern when we're talking about rainscreen, but certainly as you're looking at, kind of sealing off your building and making sure the enclosure works effectively, groundwater does need to come into the picture. And so as we look to dry our walls out and handle the moisture that we see coming into our walls, we have different mechanisms to navigate that as well, right? So first and foremost is evaporation of water at surfaces, right? So if we have beaded water, we want to make sure that that can evaporate into the environment based on those kind of climate and temperature shifts. We also want to, sometimes use the benefit of diffusion, right? And kind of allow for vapor to diffuse through our assemblies to dry out effectively. And again, in hot, humid climates, that might move in a different direction than in the colder climates. But in many areas of North America, we have mixed climates. And so sometimes we're trying to activate and use that vapor diffusion both inward and outward to escape that water vapor and to prevent any sort of condensate moisture from collecting and remaining within our walls. We obviously have drainage as well. So as liquid water is getting into our assemblies, there are tactics for allowing water to drain out through cavities, open cavities that sometimes also, benefit from ventilation, which is our item number 4. So making sure that we have, a drainage release at the bottom and the ability for air to release at the top to help promote, convection, kind of like the chimney effect of drying walls out through active ventilation by having an air exchange within our walls. So that's not always used in all assemblies. We'll talk about how that certainly integrates within the rainscreen wall. And so when it comes to managing liquid water in our walls, we have 3 approaches for that in general, right? First, we'll start with what we would call a storage or a mass wall. These are built walls where the structure themselves are built out of fairly resilient materials when it comes to moisture, whether or not that's rubble or masonry or sometimes composite layered assemblies. These types of materials are meant to be that water break right on the surface. Sometimes they can take on water, but it wouldn't be to the detriment of those materials, and they will eventually be able to release that water without compromise to the integrity of the building. We don't see a tremendous amount of storage or mass walls now that we have energy code requirements. We see certain assemblies moving away from that, but this is certainly a way to manage liquid water within our built environment. We also have exclusion walls, right? So not too different from that mass wall, but these types of walls are not taking on moisture, and they're really meant to be perfect. They're navigating the water on the exterior side, and they have a primary location where that liquid water can hit and drain to the bottom, right? They're not integrating drainage planes intentionally behind those assemblies, and water is dealt with right on the surface. And that's a critical component within the detailing design and certainly construction of these types of exclusion systems. And then last but not least, you have what we would call a drainage wall, right? So with these, not that you don't have intent of handling water on the surface of the cladding, you certainly do, but there's incorporated and intentional drainage paths within the wall itself to help navigate and manage the liquid water that will likely make its way behind the cladding. So this is not relying on the perfection of the exterior cladding, but helping to promote other tactics within the assembly to drain and evacuate that moisture. And you can see a few different examples here, from masonry veneer to lap siding to many of the panel cladding systems that we see installed within kind of rainscreen walls today. And so kind of the hierarchy here in terms of types of walls, right? We're going to start here as we look at this chart on the left-hand side with what we would call a perfect barrier system, which again really aligns with that exclusion wall that we showed on the prior slide. And we call it perfect barrier because these types of barrier systems do need to be perfect, right? Whether or not they're face sealed systems, or in sometimes you might have, like in an insulated metal panel, a concealed barrier that's dealing with these sealants on the exterior face of the cladding to really try to navigate and prevent moisture from ever entering the assembly. It's not meant to really navigate any sort of breaches in that. And so if there are imperfections or issues, it becomes a little bit more challenging to navigate and control that water that gets behind that essential barrier. And then we'll talk on the right-hand side here about the imperfect barrier, and not to kind of confuse people and say that we're promoting something that's imperfect, but I think the intent here is that we know that it's hard to make things perfect. And so these assemblies are meant to recognize that moisture will get behind that first layer of defense. And so there's intentional mechanisms to manage that moisture once it gets behind that. And so again, with the master storage walls, that's handled through the actual materials themselves, right? So like brick, masonry, or rubble, or, kind of these mass CMU type walls that might be exposed, they can get wet. But then as you have a heat flow across those assemblies, that water can diffuse out without, much compromise to the integrity of the wall. But more often than not, and what we're going to be talking about a lot today, are these drained or screened walls where you might have closed joints, or you might have open joint claddings, but then you're integrating cavities of certain parameters to navigate that moisture behind the cladding, and integrating specific water resistance kind of components to help navigate that as well. And that's going to be broken down into a few different categories here. You'll see vented, ventilated, and then ventilated and pressure moderated. And so we'll talk a little bit about those differences as we go forward here in today's presentation. And so the Rainscreen Association in North America has developed a current definition through the definition committee. And I will read it verbatim here just so people are familiar with what we're talking about when we say rainscreen, which is an assembly applied to an exterior wall, which consists of, at a minimum, an outer layer, an inner layer, and a cavity between them, which is sufficient for the passive removal of both liquid water and water vapor. And so, as we look at a diagram here of what that is, and we're looking at on the left here, a plan section, and then on the right, the actual vertical section, right? So number one here would be identified as our outer layer, which could be the cladding. Number two is our inner layer, which here is represented by a water resistive barrier over the sheathing. Number three, you'll see, is this air cavity, which is a space in between that outer layer and the inner layer. And then that space has to be sufficient for both the passive removal of liquid water, which you see here in blue, and water vapor, which you see here as the dotted line in 5, right? So that's kind of what we're talking about when we discuss rainscreen. There's different ways to do this. And in fact, almost any cladding and backup wall separated by a cavity that is drained and vented or ventilated would qualify by this definition. And so again, this is not a product, material, or building type specific assembly. It can be applied to a variety of types of buildings. It can integrate lots of different sorts of materials. Just as some examples here, starting on the left, we might be looking at residential construction, or maybe multifamily wood frame construction, where again, you'll have, let's say, maybe a fiber cement cladding. You'll have fur-in strips to kind of help provide that cavity space. You'll have a water-resistant barrier up against that sheathing. That's a very common assembly here that we see in North America. When we move to more commercial construction types that are, let's say, are steel framed or metal framed walls, not too different from what we see on the residential end, but you'll notice here maybe one difference is as now we have exterior insulation thrown into the mix. But we'll still look at that inner layer really serving as that water resistive barrier. You still have your cavity space between the insulation and the cladding itself. And then that cladding can be all sorts of different types of materials, from obviously ACM to steel plate, aluminum plate, to other types of composite materials that would service in that position. And then last but not least, we're seeing here, concrete or CMU walls with exterior insulation as well. And really the difference here is now all the insulation in this wall is now being pushed to the exterior side, but the other parameters remain the same. And the three primary components are still recognized as far as an outer layer, an inner layer, and then a cavity that's going to help promote the passive removal of, again, that liquid water as well as water vapor. From the continuum side of our walls, this was generated through the technical committee at RAiNA and supported through RDH consultants. So, this is the content that we're showcasing here, which really gives you, kind of when we look at framed walls, how are the differences out there? Where do we start to see rainscreen walls come into this continuum? And so as we start on the left-hand side, which is categorically the non-rainscreen walls, we'll start far on the left with face sealed systems, right? Where you have a tighter profiled, let's say, metal cladding, and there's no specific backup for drainage, right? It's meant to be sealed at the surface. It's not meant to permit or allow water from getting behind that cladding. That can also be done with some concealed barriers, where again, it's basically a sealed system, and there's no specific detailing for drainage or flashings within these systems itself, right? So there is some level of water control, but it's not really intentional from a drainage or a ventilation space side of it. There are some assemblies that will include levels of drainage, minimum levels of drainage, and you can see that, again, with flat cladding with maybe a textured house wrap. But the intent there with the drainage and venting might not be as you would see with the rainscreen wall. And so as we move to the right-hand side of this chart, now we're looking at some levels of intentional venting, whether or not that venting is incorporated through entangled mesh or through maybe a dimple sheet type product behind the cladding itself, where we might not have a release at the top of the system, but there's certainly a level of intention to the drainage at the bottom, and certainly getting venting there to release some of the vapor as well as the liquid water. Drained and ventilated is what we see most commonly within the rainscreen walls, where you have not only a release at the bottom for drainage of liquid water, but you also again have that release at the top that's going to allow for that air exchange and that air movement to help rapidly dry those cavities out and to diffuse the moisture that's within those assemblies. And then in some cases, you'll have what we call pressure moderated or pressure equalized systems that start to compartmentalize these assemblies to reduce the pressures that are acting actually on the structure itself, the negative pressures that are acting on the wall, driving the moisture into the wall. So that is certainly another component that would fit within the rainscreen wall continuum. So again, at a minimum, rainscreen includes an outer layer, cavity, a water resistive barrier, which would serve as your inner layer, and then you've got your structural backup wall. And it's important to note that flashings and the openings for drainage are certainly integral to the performance of these assemblies as well. But we can't forget that there's other things that are included here, right? We mentioned on the prior slide that was at a minimum, but we commonly also will see cladding support, right? To support those claddings. The claddings don't always have integral fur-in strips or mechanisms to create that cavity space. So in terms of attaching those claddings back to the structure, we have to recognize that. We have exterior insulation, which our IECC is now requiring in I think all jurisdictions. So we have to recognize the layer of continuous exterior insulation that needs to be integral to these assemblies. Oftentimes, while of course we're going to have that water resistive barrier on the sheathing, It's not necessary that it needs to be your airtight layer, but oftentimes we see it designed and implemented as an airtight layer. And we'll talk a little bit more about that in the future, but it should be, recognized that just because you have a water resistive barrier, it doesn't necessarily mean that that water resistive barrier is meant to serve as an air barrier and meant to be installed airtight, right? And then with many of these assemblies, that same membrane can also provide some level of vapor control, right? It could be, completely vapor impermeable, serving as a class 1 vapor retarder, but maybe it's vapor permeable, maybe there's intent for its permeance, but nevertheless, it's controlling some level of vapor diffusion within the assembly. And so that is also part of a rainscreen wall as it's designed. And so just kind of going through those first initial slides, I think we can all recognize that there's a lot to consider with a rainscreen wall. And so we're going to go through the various components, within a rainscreen to kind of identify what they are, identify the considerations, identify how maybe there's unique considerations for each one of these components, but then there's also shared considerations within how the assembly works. And so we're going to start with claddings, probably fairly simplistic, and we probably are familiar with a lot of claddings that promote themselves as rain screens in and of themselves, but obviously they need to be part of a system. But really almost any material can be used as part of a rain screen wall and used as a rain screen cladding. Some very common examples that we would see in the commercial market. Obviously, I mentioned already ACM. We also see high pressure laminates, fiber cement panels, concrete, porcelains, stones, terracottas, brick, of course, maybe wood-based products. And I'm sure there's some other composites out there that can be used as compact panels within a rain screen assembly. Some of the considerations that you need to make, obviously with these claddings is their exterior finish, right? Making sure that they are water shedding, that they're non-absorptive for the most part. And that they're going to be unprotected from the environment, right? So from a durability standpoint, they need to be kind of UV resistant. They need to be able to stand the test of time based on what the expectations are for the construction that's being assembled. These assemblies are going to include the interfacing of joints. Some of them might have closed or concealed joints to kind of provide some extra protection of liquid water from getting behind the cladding. Some of them might have open joints. Obviously, we mentioned before flashings to evacuate water to the face of the cladding. You might have some other trims and accessories or fire blocking, depending on where and how you're building, right? So this is all paramount to the cladding discussion. And then, of course, if we are going to incorporate open joints or perforations within our claddings, now we're starting to expose the bones of the system to additional water. We're exposing it to higher temperature differentials, UV exposure, maybe more exposure to insects and pests within that cavity. And so those are considerations that we need to be aware of and how that integrates and how we need to protect against any sort of impact from those environmental factors. And then last but not least, based on where you're building and what types of buildings you're constructing, things like combustibility and spoke spread are certainly paramount to this type of an assembly, and consideration should be made around that. And this is not meant to be an exhaustive list of the considerations for claddings, but I think, again, from the unique side of it, that all, let's say specifiers or design professionals will consider is, what are the colors that are offered? What are the sizes? Again, what is the durability, the UV resistance that's related to this? Do we have to provide any level of edge treatment if we're cutting these panels? How do we navigate that? But then there's a lot of shared considerations, really, that are system specific, that are going to kind of tie in to the other components of rainscreen. For instance, deflection criteria, right? So each panel might have a different level of deflection requirements that could dictate how frequent you need to attach those claddings back to the wall, right? So it's going to tell you how often you need to have an extrusion there to support the cladding. And if you don't abide by that, you might have some waviness or some unintentional bends within the panels themselves, and that's going to vary based on cladding per cladding type. The cavity, right? And this shouldn't be overlooked by any means, but the airspace in the gap, again, is critical within these assemblies. At its bare minimum, it's going to inhibit the capillary action within these assemblies to prevent the water that might hit the surface from transferring from that outer surface to the inner surface of the wall or the rain screen, right? So it's going to allow for that drainage. The airflow within that assembly is going to also help to evacuate any water vapor that either migrates into the wall or that's trying to maybe get out of the wall, and to kind of safely remove that from the assembly. This air cavity can also have impact on the fire and smoke propagation within walls. We haven't talked about it yet, but we may be familiar with what is called NFPA 285, which is a fire assembly test that's commonly used in these rain screen walls, or for any walls, exterior walls for that matter. And so, we should recognize that cavities or open spaces can impact both fire propagation and smoke propagation. So considerations need to be made on that as it pertains to that gap. And then if you are doing pressure moderated or pressure equalized systems where you want to really compartmentalize that cavity behind the claddings, considerations need to be made for that cavity specific to those types of walls. Obviously these air cavities contribute to the drainage planes within exterior insulated walls. But when we talk about exterior insulated walls, I think it is important to note within rain screens, as opposed to a perfect wall, a perfect barrier system, rain screens do have multiple lines of drainage planes, which can really contribute to, a more optimum performance and more control over liquid water. And so, unlike those kind of perfect systems, rain screens include, again, these multiple planes. One is going to be at that face of the cladding, right? So when the water hits the wall, you do have a drainage plane right at the cladding side. If you have open joints, or even if you have closed joints where water is able to find its way behind the panel, you do have the back of the cladding, which also serves as a proper drainage plane within these walls. When you have exterior insulation, that could be made up of a variety of rigid forms of insulations. Those insulations are typically designed to be water shedding and should be within these walls. And so the face of that insulation is also going to serve as a drainage plane within these walls, right? So if water makes its way behind the cladding, is able to jump your cavity and get to the face of the insulation, you have a third line of drainage right there at the face of the cladding. And then, of course, we can't overlook that we do also still have a specific water resistive barrier within these walls that's typically placed directly behind the insulation over the sheathing, acting as a fourth and final line of defense for moisture control, right? So there's a lot of redundancy built within these commercial rain screen walls that do help to contribute to performance. Also in line with the cavity discussion, and I mentioned vents and venting and ventilation. It's important to note that there's different ways to achieve that within a rain screen. We could just be looking at systems that purely have venting. And what that means is that there's only an opening at the bottom of these systems to allow for drainage and to allow for low flow air rates within these walls. And so a detail here, this section detail on the left, you can see what that looks like to again allow for that moisture to evacuate from the upper section out to the face of the panel. But when we talk about ventilation, right, and kind of looking at the promotion of air exchange within the walls, now what we're seeing is that this flashing component in between the horizontal panel joint, we see that there's intent to allow for an airspace at the top of the cladding, right? And so this is now allowing for that that air exchange. This convection kind of chimney effect is allowing for a higher airflow rate within these walls to help quickly evacuate any sort of moisture or moisture vapor within these assemblies. And so that's kind of a primary difference between what we would call vented versus ventilated. And so the amount of venting or ventilation, needs to be, performance depends on several climatic factors for sure. And while it can be beneficial and oftentimes is beneficial within these walls, it's not always necessarily the case. All right, so another component within the assembly is obviously the water resistive barrier. And this oftentimes makes up the inner layer of the rain screen. It's located inboard of the cavity itself. For many of those out there that have kind of been involved in these walls, you're probably fairly familiar with the products that are used as your water resistive barrier. And again, this doesn't have to be serving as your air barrier. Oftentimes, if you look at kind of polymeric membranes that are mechanically attached, those are often acting as water shedding layer. They might have some slight benefit on air tightness, but unless they're fully sealed, it's hard to achieve air tightness with those types of products. And certainly those can be used within rain screen walls. We see here in this isometric on the top right, kind of representing that. But we also see a lot of self-adhered membranes, things that are fully sticky to the wall. We see fluid applied products that are troweled on and taped or seamed, with different types of sealants at the joints. And so, those also serve as water resistive barriers. It's usually not a single product. These WRBs, you have to integrate those kind of components. You have to follow the proper lapping, the taping, the sealing, which make it part of that kind of system. And again, they can be part of an air barrier system and obviously provide some level of vapor control, but that should be done as intent through the design and construction process. And many of these products will, have an impact on the combustibility and the smoke spread within the rainscreen cavity. And so considerations as a system need to be made by the integration of these products. And so in general, right, there's always going to be some unique considerations for water resistive barriers, from durability, UV resistance, dimensional stability in terms of movement. They might have different sorts of fire requirements. They might need to meet specific air tightness requirements as a material or even as a system. When we talk about open joint rainscreen, certainly the UV exposure, long-term UV exposure is paramount to the kind of decision-making process. And then, of course, there's shared considerations that are going to be kind of aligned with the rainscreen as a whole. I think first and foremost, I'm not going to go through all of them on the list here, but one of the key ones is penetrations, right? So, we talk about a water resistive barrier or even an air barrier as part of this assembly. But you got to attach cladding to it, right? So you got to put a puncture within these membranes to attach these structural components to the wall, or these kind of cladding components to the wall. And so how do you navigate those penetrations? How do those systems to attach the cladding integrate with these membranes and maintain that necessary water control or air tightness control within these walls? And so as an industry, we have to recognize that and how to do that effectively. So here are kind of some more details of what that would look like. All right, so moving on from membranes, now we're talking about cladding attachments. So again, the cladding won't attach itself for the most part. Sometimes that is the case, but for the most part in a lot of these commercial systems, we need mechanisms to support that cladding off of the structure to promote not only that ventilation and drainage cavity, but oftentimes to incorporate exterior insulation, which again is becoming much more prevalent. And so we're looking at kind of plan sections of different ways and mechanisms to do that. On the left, you might see certain claddings that might just use an entangled mesh or some sort of a polymeric product to keep those claddings off the wall while promoting drainage and ventilation. You might see in the middle here, a hat channel or a furring strip right off the sheathing, again, to support that cladding and to promote that air cavity. And then you've got here on the right where you've got some exterior insulation. And so, as our energy codes are shifting, we have to be very careful on how much of that cladding component is breaching that insulation and impacting the thermal performance of those walls. And so, we now know that we want to minimize the thermal bridge from a rail or a clip that's going through that insulation. So there's a lot of new technologies out there that need to be considered to help carry that cladding flush or to the face of the installation without creating a significant linear or point thermal bridge through that insulation. So this is just kind of an array of systems that we see commonly used out there to help minimize that. Different types of clip and rail solutions, some components made out of metal, some components made out of fiberglass. Fiberglass being less conductive than metal can help contribute to higher effectiveness, thermal effectiveness of these assemblies. Sometimes we're now seeing rigid insulations being used that have a compressive strength to support the cladding flush of the insulation without using any clips or rails, but maybe just fasteners that can penetrate the insulation and again reduce that thermal bridging down to point bridges that you can see here in the lower right. So these are all considerations that we need to make for these systems. And so for these types of extrusions and component systems, obviously durability is key, how they contribute to fire performance ratings, how they're contributing to the sustainable built environment overall. But a lot of these times, I mean, this is the peanut butter that kind of connects the wall to the cladding. And so there are a lot of system related impacts here, from structural integrity, dimensional stability. How do we make sure we have a flush surface to maintain the extrusion system for the cladding? A big part of this, again, if not to emphasize enough, is the energy code compliance, right? How are these systems navigating the thermal bridging within these walls to optimize performance and reduce even condensation or moisture within the walls by eliminating that thermal bridging? And of course, exterior insulation, we've referenced it a lot already, but this is becoming much more paramount in these wall assemblies to provide thermal control, to meet the energy code requirements, oftentimes to navigate the condensation control within walls, to minimize the impact of dew point within your wall assemblies, or to place it in the right location. Sometimes these products are chosen for fire protection as well. Considerations that need to be made are the air and vapor permeance of these materials, depending on the walls and where you're building these walls. We might want to ensure that we're optimizing vapor drive outwards. We might want to make sure we can tape these products if they're serving as our air barriers. So considerations can be made there. If these products are in these assemblies and they're exposed to water, if they're exposed to UV, if they're exposed to the environment, how well can they navigate that, and how do we integrate water resistance within these assemblies using exterior insulation? And of course, we have to have the fire considerations because there will be some level of combustion smoke development created by these parts and pieces within these walls. So again, lots of things to uniquely consider with these products, from, let's say, nominal R value to long-term R value to durability and resilience within these walls. A lot of shared considerations within the assemblies. Certainly, we want to make sure that we're attaching these products within these walls so that they stay there effectively. We're looking at a photo here on the right, where maybe the adhesives that were used were not optimum for these products, and certainly for thermal insulation to be effective, it needs to sit flush against the wall. So, a lot of considerations that need to be made. And it doesn't stop with the assembly, right? I mean, design and construction professionals do play a role in this, and there's considerations that they need to make, from the aesthetics, right? They're going to be the ones that are choosing the colors, the textures, the profiles, the depth of these products, the grid and the patterns. Are we using concealed fixings that might add certain components within these rain screens? Can we use exposed fixing that might create some levels of simplification? Are there perforations or penetrations that are needed to be integrated that require more onus on water control within the walls? And so we have to think about that. Designers, whether or not it's the architects or more often the engineers, have to recognize the structural loads that are being applied to the wall through these systems, whether or not that's wind or seismic, any sort of dead or live loads. Those things need to be in there. Environmental loads, anything from, again, those wind loads to driving rain, snow, ice, maybe fire. Those types of things need to be part of this as well. And then certainly the combustion loads that we've referenced throughout, and recognizing how the fire testing requirements can dictate some of the product decisions. And so there's a bunch of test standards out there, ranging from all sorts of different products that are implemented into these assemblies, and even system related tests. This is not meant to be an exhaustive list of reference standards, but you can see there are a lot of standards across these various products that do need to come into consideration. And so currently there are a couple of AIA tests that are on the market today that do recognize and address specifically to rain screen. There's the AIA 508, which again is more of a classification method for pressure equalized and moderated rain screen assemblies. There is a AIA 509 as well, which addresses the drain and back ventilated rain screens. But the AIA 509, is more of a classification method. It is not a pass or fail test. So it doesn't tell you whether or not this is a good design or a bad design. It lets you know, okay, this test or this assembly is allowed this much water behind the cladding, but it also allows a significant amount of ventilation. And it doesn't tell you if that's right, wrong, or indifferent. And so there's still a little bit of work to be done on kind of addressing what makes a rain screen successful versus not successful, and how do we measure that. Contractors obviously are part of this, right? We can design buildings as best we can, and implement all the right products and get all the testing considerations down right. But then at the end of the day, it needs to be installed per the right guidelines. And there's a lot of considerations that are all system related here. From the contractor point of view. And I think, one thing that shouldn't be overlooked is panel movement, and understanding that, a lot of these claddings have some level of expansion and contraction, and we need to have those considerations within the tight or sliding holes within these systems to prevent any sort of buckling or issues there. And this is oftentimes something that's overlooked within these systems, but there's a number of things here that the contractors need to get right and understand how these products integrate and work effectively. All right, so we're going to move on just to the model codes, just to kind of understand how rainscreen is currently represented or underrepresented within the IBC. And so chapter 14 kind of talks about our walls. And so you'll see there that, there's a number of prescriptive requirements within chapter 14 for a variety of products. And so I think the intent here is that, there's a lot of prescriptive requirements for a lot of different materials, but in general, we don't adhere to them, right? There's also performance requirements that we can move to. And so, chapter 14 will reference things like fire standards or structural performance requirements. They might have specific fire tests and prescriptive methods to use those materials, as I just mentioned. But chapter 14 doesn't reference energy performance of assemblies, right? This is, again, our exterior wall section. It doesn't give specific requirements around water performance of assemblies. It doesn't reference the thermal movement that needs to be accommodated within these walls. And certainly there's a lot of materials that are currently being used for rainscreen, and those material requirements are not specifically listed. And most importantly, chapter 14 does not have any current reference to the term rainscreen, right? We might see things like MCM or HPL listed in there, but it doesn't get into these other specifics. And again, when it comes to prescriptive versus performance, I mentioned a couple of slides ago, there are a lot of prescriptive requirements in there, but oftentimes we go the performance route, right? And that's how we adopt and get different types of products within our buildings that might not be listed in the IBC. We rely on these key performance characteristics. And as an example, some of these performance requirements could be, instead of having a prescriptive R value within our walls, we'll calculate the U value of the assembly, right? And that permits us to get in. Oftentimes, there's tolerances for the use of combustible materials. It's not going to tell you specifically what you can and can't use, but you're going to have to run an NFPA 285 tested assembly, and that test or the evaluation reports around those tests are often used to show compliance. Oftentimes the same is with deflection limits, which are going to vary based on product. So, right now there's ways that we work from the performance side that allows us to get into our buildings, and that's where we see rainscreens really the route that they're going. But if we take it back to that prescriptive level, if we're just building to the prescriptive requirements, they could be compliant walls, but they still might leak. You might still see cracking and bowing of panels, right? You might have some level of vapor drive issues dealing with condensation. You might end up having poor thermal performance with lots of thermal bridging that's not specifically addressed within the IBC as it currently stands. These things can lead to aesthetic failures, such as delamination, such as having unflushed substrates, et cetera. And there's other things that we need to consider. And so it's not perfect, certainly as it stands. And I think there needs to be a more cohesive approach. And so then the question is, why do we need a Rainscreen Association North America? And I think it's really to address all of those concerns, right? We need to come together. I don't know if any of you out there find this image appetizing or not. I'm not trying to entice you to find it appetizing. I think the intent here is that some really tasty things or things that we like are presented in layers, and the layers are critical for the end flavor, and the locations oftentimes really critical as well. And so it's not too different with Rainscreen, right? We're seeing an image here of what Dr. Straub likes to call the perfect wall, and it's kind of represented here in the Rainscreen. And you can see the various control layers that need to be integrated, as we've been mentioning throughout. And so, there's a lot of these parts and pieces that do need to come together and be installed effectively in order for this to work efficiently. And so then we can say, well, one organization to support Rainscreen. Well, that could be challenging, right? We've got lots of different groups of companies involved, from the manufacturing end to the design professionals to the consultants, to the contractors, to the testing agencies. And so it's not easy. This is a very complex Venn diagram, but really the successfully installed high-performing multifunctional Rainscreen assembly is going to be located at the dead center of this Venn diagram. And so who is the Rainscreen Association in North America? As it currently stands, we'll give you a list of a number of the members that we currently have. This is not an exhaustive list of our membership, but this gives you a sense of the types of companies that have decided to come together to help ensure proper Rainscreen design, testing, certifications, and certainly installation. And so Again, a couple slides here representing the different agencies. Again, this is not a manufacturers association. This is an industry association that really from soup to nuts is asking for members to be involved to kind of provide their input and their impact. And so this is not, this is as of last year in terms of the member type breakdown, but this gives you a sense of the types of companies involved, right? The majority of membership right now is consisting of cladding manufacturers or the component, right? The attachment manufacturers that you see here at the bottom. We have a number of trade associations from sheet metal workers to carpenters to the like. We have some consultants, which is really critical for all of this kind of bringing these parts and pieces together. But we have membrane manufacturers, we have different industry associations, insulation manufacturers, design professionals. So it is certainly a mix of folks. And the RAiNA vision statement as it currently stands is RAiNA is the recognized rainscreen authority supporting performance-driven rainscreen assemblies that contribute to more durable, resilient, healthy, energy efficient, and safe buildings. What we value most is the integration of this expertise, right? Bringing all these smart people and smart companies together to really to focus on best practice. That best practice will be based on building science performance criteria, right? So this is not any one person saying, "Oh, this is how we've done it, so this is what makes the most sense." But this is going to integrate proper testing to really kind of showcase that the proof is in the pudding. And we're looking to kind of encourage sustainable, long-lasting building enclosures through this process and maintaining aesthetics as we go. And so our mission statement is to work together with not only our membership, but the industry and the trade to be the recognized authority on rainscreen wall assemblies in North America. And as you can imagine, there's a lot of associations out there, like Metal Construction Association, that's done a tremendous amount of work and has a lot of expertise in this realm. MCA is a member of RAiNA. And so, we are not here to, RAiNA is not here to reinvent any wheels. They want to collaborate, and communication is obviously key. So these are some of the associations that have been involved in that collaboration, whether or not that's working on definitions committee, helping to kind of align with some of the current testing standards that are out there. You'll see that there's some European companies here as well. There are rainscreen associations in Europe that are now somewhat connected to RAiNA. And so even, currently as it stands, there's a memorandum of understanding with the Air Barrier Association, also known as ABA, that has done a tremendous amount of work on water resistant barriers. And so leveraging their support and kind of their knowledge in that realm is part of what RAiNA is doing and bringing them into the performance committees. Here's the board of directors for RAiNA. And, I won't go through all these names here specifically, but it just gives you a sense of the types of companies that are represented within the board, the types of individuals. And this is going to recognize not only cladding manufacturers and membranes and insulations, but also consultants, also contractors, also industry groups. So having voice of these different sometimes disparate groups is really important, particularly on the leadership level. And so from an organization standpoint, this is a membership-led organization. The board of directors reports to the members to ensure that the organization is exercising what the members want. And then we've got a number of standing committees from definitions and rainscreen performance, building codes, residential, education and training, and then obviously marketing and outreach. And so as it currently stands, right, I mentioned before, we have 76 member companies affiliated with the association. 48 of those companies are active members in terms of participating within our standing committees. This gives you a sense of where that activity is highest, right? So our rainscreen performance, our technical committee sees the most membership there. But all of these members have been very active. We've had, I think, so as of the end of last year, this was from October last year, we had 78 meetings within the calendar year for an association that really didn't get going until June of last year. So in 6 months, they had over 78 meetings, a tremendous amount of hours put into this association to really launch and get things going. So here are the co-chairs from the Rainscreen Performance Committee: Graham Finch from RDH and David Markman from Morrison Hersfeld. They have gotten close to finalizing a technical bulletin around rainscreen that should be launching later this year, but that was kind of their first task in 2020. The definitions committee and dealing with semantics, I think, has been one of the most interesting initiatives that we've had. And certainly one of their highlights for the first year was just coming to an agreement on the definition of rainscreen itself. And so that was and making sure that we are identifying as one word and not two, which can often be confusing. But again, they've worked closely with the AIA, who has a similar definitions committee, to kind of help align kind of the focus here, and supported some of the other committees within the association to kind of recognize this terminology. But there's a whole host of terms that they're working on as we move forward into 2021. We've got Andy Williams, who many of you might know from the MCA, as a co-chair of our building codes committee. And he and Brian Nelson have done a tremendous job. And we just were at the IBC hearings to get the rainscreen definition proposed for implementation within the code. I mentioned earlier that it wasn't in the code, and it looks like things are progressing, that in the next code cycle, knock on wood, if we can get through the fall hearings, we'll see rainscreen implemented within the code. So there's a tremendous amount of work that was done to that. We have a whole, committee dedicated on residential applications. Residential, I mean, the principles of rainscreen are the same, but oftentimes the materials and the contractors and the design professionals involved are quite different. And so recognizing that, we have some folks that are really dedicated to that and working on presentations around that. We have our own education and training committee, and again, they're currently working on a CEU presentation that, similar to what I've been presenting here today, but that would be available to all of our members to present. And that's going to be something that will be developed later this year. But the long-term vision here is also to establish contractor training programs, design training programs. So we're just at the start of this. From an industry outreach and marketing standpoint, one of the big victories in this first year was the launch of the website. So I would encourage any of you who are interested in learning more about RAiNA to visit that website. There's a tremendous amount of information there, and we'll see a lot more social media and marketing around that as the year goes on. So our 2030 vision, right? RAiNA will be a true North American coalition that focuses on the interests not only of the United States and Canada, but also Mexico. We see ourselves as an accredited standards development organization that will have testing standards that are recognized within the code. RAiNA will be, the majority of the active and growing membership will be comprised of contractors and architectural firms that are participating both nationally and locally. So we see this as a national association with local chapters. And that RAiNA will be the center of excellence for all things rainscreen, right? Industry and regulatory bodies will look to RAiNA for guidance and participation. And so I think I've gone through some of these highlights already of what's taken place in 2020. So a tremendous amount of work that's been done in year one, moving into year two. And year two has been, exponentially busier than year one. So we have a lot of expectations moving forward. And here's a vision of that website that you guys can visit. It's www.rainscreenassociation.org. And that is it. Let's see where we're doing on time. So we've got a few minutes here for questions. Judy and Kaylin, I'm not sure whether or not we had questions along the way.
Yes, we do.
All right.
We do have a few questions. So first and foremost, thank you so much for doing this presentation for us, Todd.
Yeah.
Secondly is, can we get a copy of the presentation to share with our attendees today?
Yes. So I think Laverne is still on the line. We follow up with us, and we'll get a PDF version sent out. I think that's no problem.
Fantastic. I'm looking forward to that. And then we also have another question that is coming in from Nicola. Should an airspace be vented at the top of the airspace?
So right. So in order to get ventilation within the assemblies, there needs to be a release gap at the top of that cavity, right? So in order to promote that convection and that air movement, that is a critical component to get that higher air exchange. So there are systems out there that are just vented, which are going to have lower air exchange rates, but still might be able to manage obviously the drainage and some low venting or low evaporation through that. And so, we recognize that that's a difference in design and maybe a categorically different, different type of a rain screen. So both could work under the category of rain screen. Like in brick masonry walls, we don't oftentimes see a lot of release at the top, but we do see some drainage and venting at the bottom.
Very interesting.
Yeah.
Fantastic. Do we have any other questions from the audience? Does anyone want to submit anything into the Q&A? If we don't have any other questions, thank you so much again for joining us today. If you liked this presentation, Todd will be doing a very similar presentation at MetalCon in person in October of this year. So be sure to come by and see us there. And without further ado, thanks everybody. Reminder, your AIA credits are available and your certificate of attendance for CSI are also available immediately following this as soon as you fill out the survey. So thank you again, Todd, and thank you everyone for joining us today. We look forward to seeing you at a future MetalCon Live. Bye, everyone.
Bye, everybody. Thanks again.